This is Prof G, and thanks for joining me again, Pythonistas. How about we give potentiometers a whirl and learn how we can read input from a rotated knob in CircuitPython. Let's code! So potentiometers are actually a kind of variable resistor. As you turn the knob, voltage is adjusted in a circuit, and our boards read that voltage value and report it back as a number between 0, that's when the knob is rotated all the way to the left counterclockwise, and 65,535, that's when the knob is rotated all the way to the right clockwise. Now my students are working with rotary potentiometers. Everyone received one like this, and they also received a 3-pin JST to alligator clip cable so they can easily clip their potentiometer to their circuit playground. But if you've got any standard circular potentiometer with 3 legs, you can wire it up as shown here in the Adafruit guide for coding potentiometers in CircuitPython. Now also know that not all potentiometers are circular. In fact, later in the semester we'll be working with linear or slide potentiometers like this one here, but regardless of the potentiometer you're using, the code we're about to present should work fine. Now if you have the same stemma potentiometer and JST alligator clip cable that my students have, I'm going to first show you how you can hook this up to your circuit playground. Now the bag with our potentiometer in it also comes with a JST cable with 3-pin wires. Now the pins are handy if you're working with a breadboard, and you can always clip those pins to alligator clips, but since my students also have the JST 3 alligator clip cable, we're going to set aside this pin cable that came with a potentiometer. Now this white connector is the JST connector. Always look to see which way that it plugs in since the plug only goes one way. The ridge should be at the top of the plug. Slide it in, you might have to wiggle it a little bit, and now you're ready to clip the pot to your board. Now something important to note, with NeoPixels and motors, we clipped power to V out, but not with a potentiometer. We need to use either of the 3.3 volt pads. If we use the potentially higher power V out, then we'd likely get a false reading at the high end of the potentiometer scale. So potentiometer power goes to 3.3 volt. Then ground can go to any GND pad, and the white signal wire can go to any pad that can carry a signal. I'm going to use pad A3 in these code examples. Then I'll plug my board back into the USB port, and I'm ready to start coding. Now using a potentiometer with CircuitPython is super easy. The type of potentiometer we're using is considered an analog input device. So we're going to import analog in from the analog IO library. Then we're going to create an analog in object passing in the pin number. In our case, this is going to be board.a3, and we'll call this object just potentiometer. And then in our while true loop, we'll print out the potentiometer's value property, and we'll sleep for a quarter of a second between readings. So let's get going. With your board plugged in, let's launch PyCharm. And if you're new here, welcome. You may want to check out the earlier lessons in the playlist so you know how we got here. I'm going to start by deleting everything in my board's code.py file. I'll add a comment, potentiometer.py, and then I'll import board, time, and from analog IO, I'm going to import analog in, capital A, capital I. That's the class we're going to use from our analog IO library. Then I'm going to create my analog in object by saying potentiometer equals analog in, and then I'm going to pass in board.a3. And just so that you know, instead of using from analog IO import analog in, I could have just done an import analog IO, but then I would have had to refer to down here setting the potentiometer equal to analog IO dot analog in. So all that really did was it saved us a little bit of memory and a little bit of typing. Either way you do it, if it works, that's fine. Just above the while true loop, I'll print out a statement so I can see my code is running. Print potentiometer code running. Then down here in the while true loop, let's print with potentiometer dot value. Let's pause a bit between readings. Time, sleep, and in between we'll pass in 0.25 for a quarter of a second. Save this, open terminal, make sure TO is running, and now let's turn the knob of the potentiometer. And the view of the potentiometer isn't very exciting, but you can see as I turn clockwise, my numbers go up. If I turn in the other direction, the numbers go down, and they're from 0 to 65,535. And again, expect a little bit of fluctuation as you use this. The numbers don't remain constant, so if you turn all in one direction, they'll be 0 most of the time. But because of the nature of the analog reading, you're going to see a little bit of fluctuation. So why don't we save this to our CircuitPy folder as potentiometer.py and then close that outermost tab, and I think you're ready for a challenge. This is called the Rolling the Lights Challenge. Modify your code so that when you turn the potentiometer, you light up the lights on your circuit playground. So if you turn to the left counterclockwise all the way, you should see no lights on. Then if you turn to the far right, you should see all the lights on. You want to progressively turn those lights on or off as you rotate the potentiometer in either direction. Why don't you use blue as your color? And note that you're actually writing code for 11 positions, one for each of the 10 lights, but also another one when no light should be showing. I have confidence in your skills. I know you can do it. Why don't you pause? Give it a shot. And let's resume and compare answers. So let's change the comment to read potentiometer-rolling-the-lights and make sure that we import NeoPixel as well. Then let's set up our light code. We'll say pixels equals NeoPixel.NeoPixel, capital N, capital P, and in between parentheses, we'll say board dot all caps NeoPixel, comma 10. We'll create blue all caps in between paren 0, 0, 255, and black all caps equals in paren 0, 0, 0. I'll change my print statement so it says potentiometer is rolling, just so I can differentiate this. And instead of printing out the potentiometer.value, I'm going to set that equal to a variable named reading. This way, if you adapt this code to a different kind of sensor, it could be just whatever that sensor reading is. Next, we want to calculate the number of lights to turn on. So I'm going to call that lights_on, and I'm going to set that equal to reading times, and let's think about grade school algebra. We want to consider 11 different segments in our reading. One for each light, 0 through 9, so that's 10, plus one segment, which would be the lights off. That's the 11th one. So we're going to say between parentheses here, 11 divided by the maximum possible reading for our sensor. That's going to be 65,535. And to make our code a little bit more reusable, why don't we change these literal values in here and set them to variables up top. So I'm going to set number_of_options above my while true equal to 11. So that again is 10 lights plus no lights on. Then I'll create another value for max_reading and set that equal to 65,535. And again, that's the max value for the potentiometer. Other sensors may have different max values. Then I'll change my 11 to number of options and 65,535 to max_reading. Now there's one more thing that's very important. This number's gotta be a whole number, but we know how to do that. We're just going to take this entire equation and put it inside of an int. So I'm gonna highlight the whole equation. If I type an open parenthesis, PyCharm will put both an opening parenthesis before the highlight and a closing parenthesis after the highlight. And just in front of the outer parentheses, I'll type in int. That's important because you're never going to turn on a fractional light. They're always going to be whole numbers. Then for debugging purposes, it's always useful to print out your values that are significant. So we're going to say print, and in between parens, an F string, in between double quotes, number of lights to turn on, colon, and in between curlies, lights_on, comma, reading, colon, and in between curlies, reading. Then let's create a for loop that's going to go through all of the lights in our range for the number of pixels or the number of lights we could potentially turn on. So we'll say for I in range length, len, and in parens, pixels. Colon at the end, that's going to go through the values 0 through 9. Then indented inside the loop, we're going to have a conditional. We're going to say if I, the current value in this loop, less than lights_on, colon, that means this won't be true if the number of lights to turn on is equal to 0. So we'll skip the next line. But if it is true, then we want to say pixels, and in between brackets I equals all caps blue. So that'll turn on the light in the 0 position if one light is on, the lights in 0, 1 if light 1 and 2 are on, etc. And squigglies of anger tell me that I didn't spell pixels correctly. Outdent else, colon, pixels in square brackets I equals black. That'll be sure to turn off any lights that shouldn't be on. Then let's save this. Open up our terminal with TO running, and let me get my potentiometer set up. I'll position this so that hopefully you can see the CPB here. Got no lights on, so I'm all the way to the left, and as I turn, we can see the lights going on. Remember, you got a 1/4 second delay in there, so it might be just a little not as fast as you expect. You can change the delay if you want, but you can see I can go all the way down to no lights. I can crank them up, and if I get to the other end, there are full lights on. I can go back and forth fast very quickly. So this is looking good. Your potentiometer range is calibrated to the range of the number of options you want, which is 11. 10 lights plus 1 for lights off. Then let's save this as potentiometer rolling the lights to our CircuitPython school folder and close that outermost tab. And let me show you a couple more things quickly. First, let's take a look at how we might accomplish this with slices. So let's scroll down to the while true loop, and I'm going to put a comment above my loops that says loops, and then I'm going to highlight these 5 lines here and do a command / to comment them all out. And then below this, I'll add the comment that says slices, and this is going to be remarkably easy. It's just pixels, and in between brackets, I'll start it with colon. So that means start with the very first light, which is going to be 0. I could have put a 0 in there, but colon works fine. And I want to go up to, but never reach, lights_on. What does that mean if there's going to be 0 lights on? Well, I'm going to go from 0 but never reach 0, so that's not going to put any lights on. What if it's 10 lights on? I'm going to go from 0 up to but never reach 10, so I'm going to go from 0 to 9. Then we'll set this equal to blue, and you want to make sure that you multiply this by as many lights as you're turning on, and that's just going to be times lights underscore on. That's it to get our blue lights on. And to turn off the lights, well, it's very similar. We're going to say pixels in brackets lights underscore on. We'll start at the light 1 past the last light we turn blue, colon, that'll take us to the end, and set this equal to black multiplied by, and in parentheses, make sure you put your parentheses in here, 10 minus lights underscore on. Now, the reason why this might not have been obvious is that with slices, it's okay if we're out of range. For example, if we said 10 colon empty space, well, there's nothing at 10, and we're going to go up to the 9th spot. Normally, if you were going through a loop, that would create an index out of range error, but not with slices. And just to make sure I'm running my new code, I'm going to change the print statement to say potentiometer slices. So let's save, open up the terminal with Tio, and check this out. Print statement whizzes by, looks good, so let's pick up the potentiometer, all lights are off, and we'll start turning clockwise. You see the lights going on until all lights are on, then off. We see we've got no index out of range. This is working great. 2 lines of slice code beating 5 lines of for loop with if statement code. Now, you might have noticed if we turn the potentiometer clockwise, the lights move in a counterclockwise direction, which isn't a very good UI. You probably want the knob and the lights flowing in the same direction, so let's change that. So I'm going to comment out these 2 lines of slice code, and we'll put in a new comment that says slices in opposite direction. Match the potentiometer turn. And here to go opposite, we're going to say pixels, and in between brackets, we're going to say 10 minus lights on colon. So think about it. 0 lights on, that's going to go from 10, and the colon says go up to the last light, which is 9. That's going to turn on no lights. 1 light will go 9 colon to the end, which is 9 to 9. And 10 lights on is 10 minus 10, which is 0, and 0 colon with nothing at the end will go from 0 to 9. Then we just set this equal to blue times the number of lights on. That's the same number we lit up before, just in the other direction. And below this for the black lights, we're going to say pixels, and in between brackets, we'll say nothing before the colon. But for the black lights, we say 10 minus the number of lights on. That'll make sure all the lights in the opposite direction are going to be off. We'll set that equal to black multiplied by the same statement we have up here, black in brackets, 10 minus lights on. And let's change our sleep to a faster value so we can see the lights pop up quickly. How about we sleep 0.05? And let's make sure this is saved. We'll open up Tio. The numbers are cooking by, and let's turn in a clockwise direction. And by the beard of Muhammad Ibn Musa al-Khwarizmi, will you look at that? Our NeoPixel lights are now following the movement of our potentiometer. Algebra in action. NeoPixels lighting up. Potentiometer whirling. And since I got all my code in here, I'm going to save this using the same name over my previous code. Again, making sure that I close that Outmost tab. With this big learning, not only did you learn to use the potentiometer using the analog-in library, but you also learned to map one range of values, in this case the numbers 0 to 65535, our potentiometer readings, to another range, 0 to 10, which corresponded to lights being off, plus the possibility that lights 1 through 10 could be on. And we use the magic of slices for less code and to match the rotation of the potentiometer knob. I hope you're feeling like a mathematics magician and an excellent engineer, Pythonista. There's more goodness to come. Continue to hack.